as I said, part 1 of this section that corresponds to section 3.4 in the textbook includes, part 2 includes part 1. Part 1 is included in this. We're going to be finding the equations of polynomial functions by looking at the graph of a polynomial function, and also if I give you the equation, you should be able to sketch the graph, but it's mainly this first thing today. And there's this other thing where we're going to be solving polynomial inequalities. So we're just diving in here. We're not learning any new math content. We're looking at finding the equation of this. And this is a problem you could have done yesterday, okay? It's a very simple problem, but I want to amp it up a little bit. There's something else we need to include that we didn't yesterday because I designed all the questions yesterday, so you didn't need to. And it turns out we don't really need to include this extra thing that I'm about to show you in this example. But we need to get used to including it just in case we need it. And the idea is this, that when you look at the equation of this polynomial function, I want you to leave a little space here after the equal sign. We know we have 3 intercepts, right? They are all clean intercepts. They're all multiplicities of 1. So this is something you probably could have come up with the equation for even before you knew about multiplicity. You would say, well, I know that if I have an x-intercept of -1, which I do, there is a factor of x plus 1. And if I have an x-intercept of +2, there is a factor of x minus 2. And I also know that I need a factor of x minus 3 because the graph crosses at +3. You're okay with that? Okay. But forget about the graph for a second. If all I told you was we have 3 clean x-intercepts of -1, 2, and 3, there's no guarantee that this is the equation of the function. There isn't. Because this polynomial function, and don't write this little bit down, this polynomial function would also have those x-intercepts, wouldn't it? I mean, I will tell you right now that the answer to this question is what we have written, okay? And I'll prove it to you in a second. But what I'm telling you is if you stretch this by a factor of 2, it wouldn't change those x-intercepts, would it? Or maybe it's not, but maybe the equation of the polynomial function could be that. That would have those 3 x-intercepts with the corresponding multiplicities of 1, 1, and 1. And here's what I want you to start including now, and this you will write, is whenever you go equation building from a graph, you say to yourself that there could be a constant factor. There could be a constant multiple in front of it. Now, I'm going to show you the way that I would prefer that you find the value of that A that I put. You can put C, sometimes I've seen C, you can put K, but I'm just going to go with A. The proper way is to look at this, well, the way I prefer is to look at this function that we've written as being something that has a missing parameter. Right? And we've done this to death almost. We've done it dozens of times between 20 and 30. So how do you determine the value of a missing parameter? What you do is you look at points that are on the graph. For example, 0, 6 is a point on the graph. So is 2, 0 and 3, 0 and -1, 0. But none of those will be useful because they will collapse the equation to 0 equals 0. So what we would do then is we would put 6 in here. We would put 0 in for x. And we would simplify this. So on the left-hand side I have 6, and then I have a multiplied by 1 times -2 times -3, which is 6. So I end up with, I'm just going to rewrite this as 6 equals 6a. When I divide both sides by 6, I get a equals 1. And that's what I would call the proper way of finding that missing parameter. How many of you, though, and I didn't really direct your thoughts in this direction, but how many of you did it occur to that this is correct with a equals 1, because when you multiply these three constants together, you get the y-intercept. It's not always going to be a y-intercept that's given to you, though. And it's not always going to be something that's obvious by looking at the y-intercept. Okay? So from now on, this is the equivalent in Unit 2 of forgetting to factor b out in Unit 1. It's huge. If I give you a written response question on the exam, and I say determine the equation of a polynomial function, and you forget that, and some students will, you're not even close to getting the right answer. That value of a needs to be determined. So once you've determined a, then you can write the polynomial function equals 1. I don't need to write the 1, but I'm going to x plus 1, x minus 2, x minus 3. Don't get me wrong. Not every question on an exam is going to have numbers that are not 1. Occasionally you'll get a 1. But don't assume it. Let's take a look at B. So we're going to go what I call equation building. We're going to build the polynomial function. I'm just going to go ahead and write y equals, because I know I'm going to have to find a missing parameter, so I might as well think of it as y right now. And I know that any polynomial function that I build based on x-intercepts and multiplicities could potentially include a value of a. And I hope you can look at this graph and see that a is not going to be 1. And it has nothing to do with the y-intercept. It has to do with the fact that the right arm is down. We need a negative leading coefficient. And somebody who does this, well, they go, okay, so I have an x plus 4. I hope you're okay with me saying x plus 4 is a factor. I have an x plus 1. Yes? I have an x minus 3 quantity squared, correct? Because that x-intercept of 3 is tangent. We can see it has a point of tangency. So that is an even multiplicity of 2. And for all of these, we're assuming minimum multiplicity. So let's say, for example, that I asked you, and I'm going beyond the question here, but I think that's okay. If I asked you, what is P of 1? You know, if that was an exam question, I give you this graph, and I say, what is P of 1? What so many students do is they write out this for the equation, and then they put 1 in for x. And multiple choice, wow, I got it right because the answer's right there. It's not going to be right because they've failed to take that step of finding out what a is. By the way, you can see at 1, it's going to be negative, and if you put 1 in here, you'll get positive. It's going to be wrong. Okay? So you need to include this, and just to make sure this is not part of the question. This is me going off script here, I guess. So how is it we determine that parameter? Well, we use the coordinates of a point. And let me write this down first. So we know that when x is 0, y is negative 40. I want to explain to you what I touched on in the last example, which is that it's not always obvious what you multiply by to get the right y-intercept. Do you agree that if you expand this out, and there's no need to write this down, if you expand this out without the a, your constant term is going to be 36. It's going to be the 4 times the 1 times negative 3 squared times negative 3 times negative 3. It's going to be 36. So it's a y-intercept of 36, but the y-intercept here is negative 40. So if I asked all of you, what number do you multiply negative 36 by to turn it in, or positive 36 by to get negative 40? That's not a simple question. If you're really, really good with numbers and fractions, you can work it out. But it's a question that if you just try to answer it, you're bound to make a mistake sooner or later. So thinking of it as an ordered pair being put in to determine the value of A is better. How many of you feel as though you do know what you would multiply 36 by to get negative 40? So nobody. Well, it's going to be negative, right? I believe it's going to be negative. I can't even do it with confidence. I want to say something and I'm not going to because then I'll just embarrass myself. It's not a simple thing. So what we do instead, sometimes it is, don't get me wrong, if this number at the end was 20, then A is negative 2, right? But it's not often that simple. So we put in for y negative 40, and here we're going to put 0. Should be no surprise that you get a number of 36 here. So we take negative 40 over 36, that's the answer, which is negative 10 over 9. That's not what I was going to say before. It really isn't, I'm being honest with you. I think had I thought this through in my head, I would have said, oh yeah, A is negative 10 ninths. So now we know the equation of the polynomial function. And we should write it out. We should write P of x or f of x or y, or I don't care, equals negative 10 ninths times x plus 4 multiplied by x plus 1 multiplied by x minus 3 quantity squared. So that's our answer. And now, I mean, you know by now, I hope, this is not just, we don't learn stuff in this course to ask you simple, basic one-step questions on exams. If I go back to the beginning here, I said maybe the question would give you this and say, what is the value of P of 1? Well, now you can put 1 in for x and calculate it. Okay. It could be, no, I won't go there yet. So that's B. Any questions with B? This is mainly what the lesson is about. So if I ask you for the equation of this polynomial function, your general kind of template is going to be P of x equals A multiplied by all of the factors that we can tell exist based on the shape of the graph, which has to do with multiplicity, and the x-intercepts around those shapes, or those shapes around the x-intercepts. I see an x-intercept of negative 3 with a multiplicity of 1. So it's x plus 3. I see an x-intercept of negative 1 with a multiplicity of 1 as well, because these are both clean, so it's x plus 1. And then I see that since this is positive 5, I will have x minus 5 as a factor, but it occurs twice because of the multiplicity of 2. And by the way, I don't remember because I didn't watch the whole video. I don't remember the language I used, but we can say that x-intercept has a multiplicity of 2. We can say that 0 has a multiplicity of 2. We can say that factor has a multiplicity of 2. And one other thing before we finish this. This is a multiplicity of 1. This is a multiplicity of 1. This is a multiplicity of 2, correct? The degree of the polynomial is always the sum of the multiplicities. I mean, let that wash through your brain for a second. If you add all of the multiplicities together, assuming we're talking linear factors, you will get the degree of the polynomial. This is a degree 4 polynomial because we have a multiplicity of 1 and 2. 2. It's a multiplicity of 4. I mean, if one of the factors is quadratic, which we're going to encounter in the review, if one of the factors is quadratic, then that would count as a degree 2 towards the total, but it would have a multiplicity of 1. Okay, so how do we find A? Well, we can put in 0 for x, negative 50 for y. I know that many of you maybe get tired of me drawing this table. I think the table is a nice visualization of what we're talking about here. But there's lots of points. This is just one of them. You know, if we look at trying to just sort this out based on a y-intercept, how many of you see, with a bit of thought, that the constant term with an a value of 1 would be 75? 3 times negative 5 times negative 5 times 1, positive 75. So I'm capable right now of saying that I have to multiply 75 by negative 2/3 to turn it into negative 50. I'm confident in that. But that, if you have to demonstrate it, but this is another important point, I suppose. If you're asked to do this on a written response, trying to explain how you know this is negative 2/3 just intuitively or wrapping your head around the numbers is difficult. It's difficult to do well and get full marks, whereas doing this and solving for a requires no words. It really doesn't. If you wanted to, just to hedge your bets to make sure you're doing things right, you could say, since the point 0, negative 50 is on the graph, it makes the equation true, and then put it in. So what we're going to get over here is negative 50 equals 75a. Because when you multiply out those numbers, you'll get 75. And that means a is negative 50 over 75, which is negative 2/3. So the equation of the polynomial function is negative 2/3 x plus 3, x plus 1, x minus 5 squared. Are we okay with that one? Okay. Just to give you a flavor for perhaps a numerical response question, what would I do here? Well, there's lots of ways I could do it. I have 5 digits, though. I mean, I guess I could do this. What are the values of a, b, c, and d? We don't normally do that where you happen to have, in this case, a b and a b because they happen to be the same number. Maybe in reality I would do this. And you know what? I think I would have to. Because if I just had a over b here, then you could say it's 4 over 6, which is 2/3, right? I have to tell you it's reduced to lowest terms. So a would be 2, b would be 3, c would be 1, and d would be 5. Okay. Lots of ways I could test you on this. Let's do d now. Now I changed the order of some of these in my handout this semester. Is this your d? Okay. I'm just, switching back and forth between y and p of x and f of x and that kind of thing, just to get you used to the fact that, bless you, you have to be versatile. We're going to have a constant. Just speaking of versatility, let's call the constant k, just for kicks. That k is obviously not the k in Unit 1. We are going to have an x minus 1. We are going to have an x, we're going to have an x plus 1 for that x-intercept of negative 1. We are going to have a factor of x minus 2, correct? What would the multiplicity of it be, Noah? 3. So we're going to have an x minus 2 with a multiplicity of 3 because that is an inflection point. I guess that's it, right? It's a degree 4 polynomial. How do I know it's a degree 4 polynomial looking at the graph? I do this. 1, 2, 3, 4. I count all the multiplicities and add them together. by writing out the factors, I can see that that's going to be the case. I'm going to put in 0 for x, negative 24 for y. So we'll get negative 24 equals k times, oh man. I mean, we're just kind of in learning and teaching mode here. I don't need to write zeros everywhere. You're going to end up with 1 times negative 2 cubed, and negative 2 cubed is negative 8. When we divide, we get k equals 3. So this is a case where you might have just looked at the fact that ignoring k would give you a y-intercept of negative 8, and we want a y-intercept of negative 24. Why don't we just triple everything? You know, so that intuition, or it's not really intuition, but that simple kind of thinking approach kicks in. So we can write out the equation of the polynomial function. Y equals 3, x plus 1, x minus 2, quantity squared. It's going a lot faster than I thought it would. This is okay so far? All right. I don't know what I have to look in my document and see what happened there on your printout. Is it a double vision kind of thing? Yeah. It should be saying 2 comma 15. And this, you know, is teaching us, everybody, that you can't always just rely on the fact that if I multiply all the constant terms, I can compare that to the y-intercept, because you don't know the y-intercept here. Right? But when I build this equation, I get p of x equals some number. I'm going to use c this time. We are going to have an x plus 3. We are going to have an x minus 1. We are going to have an x minus 3 quantity squared. How did I do? Good. So this isn't a case of saying, well, if I multiply out the constant terms, I'm going to get negative 27. Let's see if the y-intercept is negative 27. And if it isn't, let's find out what we have to multiply negative 27 by to get it, because you can't see the y-intercept. So I feel as though even though you could have done that with all of these, because you were given the y-intercept, since you can't do it with this one, but what we're going to do with this one you can do with any of them, always do the missing parameter thing. Unless it's obvious. Honestly, this last one was obvious. The y-intercept with a leading coefficient of 1 would have been negative 8. We want negative 24, so you triple it. So let's go ahead and put in the coordinates. We're going to put 15 in for y, 2 in for x, I think I wrote 5 because I was already thinking 2 plus 3 is 5. So I put in 2 for x. I get c times 2 plus 3 times 2 minus 1 times 2 minus 3 quantity squared, and that equals y, which is 15. So this is 15 equals, well, I have negative 1 quantity squared, which gives me 1, times 1, which is 1, times 5, I get 5c. Which means c is equal to 3. And now we know the equation of the polynomial function. We just have to write it out. Capiche? Okay. You've got about 20 minutes to work on these. Again, I would prefer that you don't work on your written response right now. I prefer that, since your mind is on multiplicity and finding that constant multiple, which I'm calling a or k or c, let's focus on that. Okay? If you want to, for the last 5-10 minutes or so, pull out that written response and get started, you can.